Ah, my mic was muted. Thank you so much, Usby, for that. I totally forgot to press the button to unmute my mic, and it was just sitting there dark in front of me. Thank you so much, Usby, for that. I suppose it could have been just a focus stream. I wouldn't have been focusing, but accidental focus stream for the win. All right, I think that's all of the warnings that are in files that we care about. We head back to the main library. In update, okay, so the handle, edges, system. We're dealing with all that. Now we do have this multiply scalar. I kind of want to test, like if this is 0.5, how does that look? Because if it is, then I want to use the turning speed for this. I mean, that doesn't necessarily look pretty terrible. I'm gonna keep it as that. We can always play with that a little bit later. So I'm gonna grab out the turning. So that turning speed is equal to okay, so that gives us that there. Now we're just all in here, so I can just throw you into turning speed. So we can play around with this. We can change this from turning speed to something like, you know, edge turning speed, or I don't know, like something else if necessary. All right, what's next? We just took a look at the avoidance system, alignment system time. What, VS Code, you don't remember where alignment system is? Cannot find alignment system. Oh, did I accidentally remove it? I probably did. There you go. Now I can go there. Okay, so alignment system. We create, we figure out the average locations of everyone. No, the average velocities of everyone around us. So we first query for everyone around us. So that's the nearby indexes. We get their velocities. If they're not empty, then we go ahead and calculate their average velocity. We normalize that. We multiply the scalar by, this should be our turning speed. Okay, so we get that out, and then I think everything else should be around the same. Am I using the site range? I am using, oh, here, we don't want that. So I don't want that multiplication thing happening. We need to pull you in. All right, let's see if we've got alignment. Oh, we're already getting an alignment. Oh, this is good. I like it. This is looking pretty good so far. Okay, and then on to attraction system. I also need to pull you in. Okay, so attraction system, we're going to remove you. We're also going to be attracted based upon our sight range. Wrap locations. Okay, so we also need our turning speed. Okay, so that's going to give us that. Then we come down here. Okay, so we're going through everything. Okay, multiply scalar by our turning speed. Now, is this in a function? This is in, handle location. So we do need turning speed in here. Oh, but we have the world in here. If we have the world in here, I can just query for the turning speed inside of here. But it's also no problem. That way we don't have to do it every single time. Let's just pass it in here. So turning speed. Okay, so you're added in there. And I'm not seeing any... Not seeing any other craziness. All right, let's test this. Now we're getting that wobbly that I see in a lot of other blocking simulations. Perhaps like the wobbly is a little bit too tight. I could make the turning speed a little bit lower for like attraction, or we could have a different radius here. So you're attracted from farther away. That might also make sense. There's also a bunch of these that are now like overlapping each other, and I think that's happening. Like they're not trying to be, but they're also trying to be attracted to each other, and the forces might be a little bit too strong. So I think attraction... I'm curious, like what if I used 0.1 on this? And so what if we had a different turning speed for this? I mean, so far so good. Okay, so this is looking much better. And we still get a little bit of weirdness, but they solved it. I'm wondering if also I want like a slightly different attraction range there. But I kind of like the way it looks right now. So to me, I think we need this to be a complete different number. So we want a turning speed for this, but we need to switch this from turning speed to attraction turning speed. and we need to add this in as a new resource. And your dot 0.1. And then I think this system is looking pretty good too. And we still have breakaway groups. I think that's good. But now they're flocking together, which is awesome. All right, I'm gonna go ahead and clean up some of this code. We made this have a turning speed again, did we? Yeah, we did. Okay, perfect. All right, warning time. Okay, Boyd, you can just add you. Okay, and then you're all good. No more warnings. All right, so around 50, I think, is around how many I can have if I were to run this in dev mode, but I think we can go significantly higher, like 500 if I run this in release mode. So let's go ahead and try running this in release mode. Why are you so much bigger in release mode? Wait a second, what number did I increase? I didn't increase the right number. That's the sight range. Oops, that's not what I wanted. I wanted this number to be increased. Oops. So now we get really interesting sort of patterns being drawn here. It's interesting how they sort of crunch together, but then separate out apart as soon as they can, which I like to see. I almost want to see this in like a 3D space. GGEZ isn't really good at 3D type stuff. So I know like Godot might be a good choice for that. Now, something else I was thinking of, there's a type of art where we can remove this clear, and so like not have everything drawn out at all, but then in this in our mesh for this, add resource, where's my bird mesh, boid mesh? Oh, create boid mesh. I have to go to here. Where's our color? Is this white? I want to actually create a new color for this. So we can make this like whatever color we want to. Color new. I don't know what would maybe look best. You can choose something like fully red and like a little bit of green and like a little bit more blue. But then I want to have like 0.01 alpha. Like very, very, like barely can see it. We're gonna throw in the color into here. And then also with our update, I'm going to, oh no, sorry. I'm gonna turn off the visualize ranges system. So we just draw the birds. Everything else should be fine. If I run this, we shouldn't see the birds, but we should see the lines sort of being created here. And this is like a little bit of a cool art. I could probably even make that even a little bit more opaque, or turn the opacity down even more. And then we can get some interesting sort of like trace lines in there. Oh, I could try changing color with time. Yeah, that could work too. We could have the color, I'm gonna make you really, really dim. And then we should see it sort of like appearing over time here. But yeah, Silency also hello. Okay, so we could change the color with time. That would be really cool. I like the idea of that. And that would play with mutating resources, which we haven't done yet. So I'm going to leave this running a little bit in the back end while we in the background, and then we'll come back and sort of like see what it looks like in a couple minutes. After they've had a chance to run over a bunch of things, we should see some traces of like that red color. Now, change color over time. There's two ways to do this. It could be a sudden change, or it could be a gradual change as we're sort of like going through colors. That either way could work really well for us. I would probably want it to be in a very gradual, like very, very slow change if it's a gradual change. Otherwise we get that like the flashiness, which is not quite as nice. But what we can do with this is we would turn you back into white. So we can have you be 1.0 again. Can have everything be white. And we can make sure that we have a resource types. Oh, we have a color in here already. Oh, perfect. In resource, okay. So in this case, we need resource names. Oh, right, because we have the background color in here. So now we're gonna add in, what would this be? This is gonna be the bird color, like the boid color. So let's start us out with pure black 1.0. And then What are you upset about? This is 0 to 0. You probably want to clear the screen with a low alpha rect to gradually dim older traces. Yeah, I think you're right. That's probably the best way, is we can have like a rectangle that just overwrites it a little bit. That would definitely work. Yeah, I don't see how that wouldn't work. Create mountain clear. Now what are you upset about? Mismatch types, expected resource. Oh, I forgot I need the resource. That. Probably a resource spelled correctly would be just slightly helpful. All right, let's take a look at, we aren't even seeing you anymore. I'm gonna come back to that after we do the color thing, because that'll help out a bit. Okay, so I'm gonna turn you, I don't need you back on. We have our bird system. I'm gonna turn the clear back on. Here's all of our boids again. They're all nice and white. So what I want to do is, wait, they shall be black, right? Oh, I set them all to this. If I set them all to black, but with full opacity. Okay, so now when I launch this, it's going to be, we can't see anything. They're all there, but the same color as the background. So then what I want to do is I want to see, hey, they're all empty. Let's start increasing red until it's 1.0. And then these are all still empty, so then we'll start increasing green until it's 1.0. And they're all empty, so then we'll start increasing blue until it's 1.0, just ever so slowly. Okay, so that means we need a new system. This is going to be our system is going to be, what is it called? Update color, like update void color .rs. Okay, so we know we're gonna take in the world. It's gonna be a reference to the world wrapper. And then I don't think we're gonna return anything, but other things that I think we're gonna need, we're probably gonna want to change the color every n ticks, or like after a certain amount of time. Perhaps like after every number of frames might be the best way to sort of deal with this. We could also just use modulus, but regardless, we still need to know how many ticks we've had. So we're gonna take in the number of ticks, which is, what does GGEZ timer return? I think it's like a U64. I don't remember. We'll find out. And then this will be that. So I'm gonna head over to the main library again, and we're gonna get that information so we can pass it in right away. After we update the rotation system, I think this is fine. We might as well do this right away, so that way they start getting new colors instantly. So this will be the update void color. Self.world, and then a tick. So this is gonna be the timer. Ticks. Oh, it's a U size. Okay, so then we pass in the context, and there we go. So it's a U size. Okay, so that'll make you happier again. So let's say if we want to do like every 5 frames, we make a color change. So that color change every let's do like 5. Then we can do if ticks modulus color change every. If you're 0, then it's time for us to do the thing. If tickies ticks. Okay. How do I want to do this? I need to get the color out. So we're going to extract the color. So that void color equal to the resource Is it that one? No, that's bird mesh. Void color. Okay, we're going to borrow mute. And then we have to cast to a color. But in this case, we have to cast to a color, a mutable color. Because if I just do that, I don't have access to the color. I could reset it, but I think within colors, I can mutate internally. So let's actually add in for color. Oh, I don't have access to that. Hold on. Where is it? Resources? We have this cast color. Let's cast color mute. Okay, you're the same otherwise. We're gonna cast color mute. Okay, which is gonna give us this mutable reference to a color, and I think you also have to be mute here. All right, so we're just not using you yet. Okay, so what's next? I want to check to see what isn't like what colors aren't set here. Let's see. So I think we can look inside a void color. So like if a naive approach would be to check if like the red is less than 1, we're just going to increase the red. I don't actually think it's going to be quite as simple as that. If the void color dot r, if that's less than 1, then I want to do void color dot r plus equals. We could do like 0.1. We could do 0.01 to make it be like even a slower increase. Okay, so else if the boid color, okay, so let's say the boid color.r is 1. Then I want to now check to see if the RG, so green, void color dot green is less than 1. All right, so now here's gonna be a problem. As soon as we reach white, which is 1.0 with everything, this entire thing stops. So if I want to reset it, I would need to have like an else if, or maybe like just an else, and then we're gonna start void color just like all the way to nothing. Like we're just gonna reset you. So void color dot red equal to 0.0. This feels terrible. I don't like it, but I'm gonna do it anyways, just to see if like this first iteration works. Because that's gonna be pretty sudden and jarring. All right, now what are you upset about? Borrow mute, cast color mute. Oh, do I need to? Okay, I need to do like a wrapped. So a wrapped void color is you. Get resource. I don't think we borrow yet. Then we can do let void color is equal to the wrap void color dot borrow mute dot cast color mute. Let's see. Temporary value. Okay, I think it's borrow mute here. There. Okay, that makes you happier. Let's see. Porkman131, hello. What language is this? This is Rust. And then inside of it, I'm using the GGEZ game framework. Okay, so this isn't ideal, but I suppose it'll work. Now we're going to come back to the main library and the draw bird system. We need to get that color out. So we're going to do that. Going to get the resource here. So let, yeah, okay, we're going to have to cast it. So this is going to have to be a, okay, so we have a wrapped color is equal to world dot resource source names, the void color. Then we're going to borrow off of here. Then we can do let the color is going to be equal to the wrapped color dot cast color. Okay, and then down here we have this drop param. So we have a destination, we have a rotation, and then we're also going to have a color and pass in the color. And expected. Okay, so then I could just clone this. Or I think it implements copy, so I could dereference it too. Yeah, it does. It implements copy. So now if we just run this, will we see them all slowly become visible? Maybe. Possibly. Did I wait? Do I still have the alpha really low? I think I changed it to the alpha is not really low. Is the changing of the colors too slow? Perhaps. Because like once every 5 frames, now that happens, we're doing 60 frames per second, so that should happen pretty fast. We should be seeing something by now. At least I think we should be. Let me create boid mesh. Here's our color. We're handing it into the triangles for the color here. Okay, and the alpha is 1. Let's set everything to be full red. If we do this, do we see at least the red to begin with? No, okay. Oh wait, no, there it is. It's interesting how it like faded in. I wasn't expecting that. Oh, wait. You all need to be white. Everything here needs to be white. If I am overlaying a color on top of something, it needs to be white so that it just accepts the new color. Because anything on black is just black. That doesn't help. So this is how we're gonna get the color to sort of fade in. It becomes fully red, and then is gonna become the next thing. Epic Blarg, hello. Unintended art, yes. So I like this. It's slowly going through the different colors. I like that until it becomes white, and then that, which is not great. What I want is to cycle through a bunch of colors. So we want like all the reds, and then we bring up green, and then we bring up blue. But then I kind of want to like, I don't know if I want to reverse it again, or if I want to like, okay, if all of them are down. Okay, if they're all ones, now let's bring down red, and then we'll bring down green, and then we'll bring down blue. Okay, I like that. So an update boid color, how are we gonna do this? Hello, SureShock. If everything is zeros on this, we're gonna bring up red. So if red is less than 1 and the other colors are 0, perhaps like less than 0 even. It's like void color dot green is less than 0, and void color dot blue is less than 0. Okay, so if red is less than 1 and all the others are essentially 0 or less, then we're bringing up red. Once red is at 0, I feel like I need to draw this out just for my own like brain. Okay, so we essentially have like R, G, and B here. So if we have R, G, B. Okay, so if we have you are, if you're 0, you're less than 1. If this is all completely empty, time for us to fill red. I wonder if this would make sense for us to, let me reset this a little bit. If we do something like, if we're completely empty. So if void color R is less than or equal to 0.0, it's really, if these two are empty, we're filling red until it's full. So if R is less than 1.0 and void color dot green is less than 0.0, less than or equal to, and void color dot blue is less than or equal to 0.0, then it's time. Okay, we're filling green. We're filling red now. So we're gonna do the void color dot R that's equals to 0.01. As soon as this hits the 1.0, this no longer gets tripped, right? Because now we're no longer less than 1.0. So at that point, now we're in this state. So if red is 1.0 and green is like this, we want to, okay, so now we want to check this. Else if void color dot R is greater than or equal to 1.0 and void color dot green is less than 1.0 and void color dot blue is less than or equal to 0.0, void color dot green plus equals 0.01. Okay, now green is filled up. It's now here. Blue is now at this point. So if void color dot red is greater than or equal to 1.0 and void color dot green is greater than or equal to 1.0 and void color dot blue is less than 1.0, void color dot blue plus equals 0.01. Okay, so now that happens all the way up until blue is full like this. That's great. Now I want to reverse down, and so I'm thinking I want to like take down red first, so that way we get like all the possible colors, right? I guess it's not gonna be all the possible colors because we're gonna miss what happens if red is full and green is empty. But I think we'll be okay. We're gonna reduce red down. So if we're all full, so if I take you down and now we want the equivalent of this, something like that. If red is greater than 0, and green and blue is greater than or equal to 1. Okay. So then I think this can be an else if too. So else if the void color dot r, if this is greater than 0 and void color dot green is greater than or equal to 1.0, void color dot blue is greater than or equal to 1.0, void color dot red is minus equals 0.01. And now we would just want to start doing this same pattern to all of them. So else if, okay, so then red, you're now less than or equal to 0.0. Green, you are checking to see if you're greater than 0. And blue, you're still that. Now it's going to be green, that goes down. And then finally, okay, so red, you're less than or equal to 0. Green, you're less than or equal to 0. And blue, you're greater than 0. Blue goes down by 0.1. And that means now everything will go down until it's 0. So I think this is gonna work. Let's find out. So everything comes up, it looks nice and red until it's like fully 100% red, and then we start adding in green. Okay, that's working. It goes to white because all of them become 1.0, and then it becomes like a mix of green and blue, and then blue, before eventually fading back to black. I like it. Look at that. That's nice looking. I like it. Now something else that we can do that we were playing around with a little bit is we can have like that tracing happen. So what would happen if the alpha was to be set to something decently low? Beautiful. Thank you. Actually don't know if we need to set the alpha to really low. The alpha might be able to stay on like this. If we go into our library and we take away this clear, what ends up happening is we never clear the screen and it's just going to stay on forever. It's just going to smear all of these birds everywhere, and it looks like this beautiful flow pattern that's happening, which is really cool. And then they're going to change color, but the previous colors still exist on it, which is really nice. This is pretty cool too. This is a lovely piece of artwork. This kind of feels like it is deserving of like an old like 1990s screensaver, something that you would have like flying around the screen. I actually like this a lot. Like this is almost perfect as is. But let's say I want to slowly fade what's happening in the background. What we can do is we can also draw a mesh, a rectangle mesh art. Yes, exactly. This is really cool. I like this as art. I want to draw a very basic, let's see. I kind of want to like also update these. It's like color change rate. We can make this even slower if we do something like this. But I want to create a resource for color change rate. Okay, so there's two things that we're going to do here. We're going to come into resource names. We're going to have color change rate. And then we're also going to have the emptying rectangle. What is it going to be called? It's going to be the clear mesh. The clear screen mesh. So these are going to be two resources they're going to add in. The color change rate needs to be an F32. We already have that in there, and we already have a mesh object, so we're fine here. So we're going to add in these two resources. So this first one, world.add resource. This can be resource names, the color change rate, resource F32, 0.0. We can make this like 0.1 to make it very, very slow. Then we're going to go into the update the boid colors. We don't need you anymore. And we're going to grab, we need this color change every would probably be really nice to have in a resource as well. So let's grab this out first. Let color change rate equals world.get resource. Okay, then we're gonna borrow and cast to an F32. Okay, so that gives us our F32. And then we can now use our color change rate everywhere that we have this 0. Now you are a U size. So if I want to add you in, we need to add in a colors change every. Color change speed. But then we need to add in a U size, which we don't have here. U size. And then we need to cast. Okay, so now we can cast usize mute. We're going to add in another resource. Add resource. Our name is going to be the resource names, color change speed, source, usize, And this is going to be a 5. Which means we can now come to update void color, and this color change every now is going to become world.get resource names, color change, speed, borrow dot cast usize. Oh, and you're a reference. Okay, so that should be still fine. Everything should still work here as expected. Now in my mesh, I want to create a function. I want to create like the clear mesh. I'm gonna take into context, and we also, well, you know what, with the context we can get the screen size from this, and that should be fine too. I'm gonna turn a game result mesh. Okay, so let the screen size is gonna be let's see, the drawable size with pass in context. That gives us this tuple with, so X and Y essentially. That's also like the width and the height, so that's perfect. Now I want to create a rectangle. So our rect is going to be a rect new. All right, so starting position 0.0, 0.0, screen size .0, screen size .1. Oh, and that's it. That gives us our rectangle. Now I believe we can do our mesh builder. New. Create a rectangle. Mode. Draw mode. You're going to be a fill. Oh, we need our color. You're going to be a color new. Going to make you black. And then just a very low alpha here. Okay, so bounds. This is our rect. And then we have the color. And then we return, oh, then we build you. Pass in the context, and we're good to go. Create clear mesh is here. Now we're gonna add this in as a resource. So resource names, create clear screen mesh, resource mesh, and then this is going to be our and pass it into context. You need to be question mark like that. So I'm gonna call them there. Okay, so now happy here. We have that in our. I don't think we have it here. We need our draw birds. Actually, I don't know if I want to have this in the same system here as the draw birds. I think what I want is to create a new system, which is clear screen. All right, so hub function, clear screen system. We know we're going to take in the world, which is a world wrapper. We know we also need to take in a context. We also know we're going to return a game result. So if I just return that right now, that'll make you happy. All right, so let's first get our get that mesh out. So that our mesh is going to be equal to world.getResource, resource names. I don't know, one of you. Nope. Let's see. This is the here screen mesh. We're going to borrow you, and we're going to cast to a mesh. Are you going to work? Or yeah, you are going to work. Okay, so now I have our mesh here, a reference to the mesh. We now need to just draw this out, and I think that's going to be it. So we're going to have a draw. Pass the context, a reference to the drawable, which we already have, and some draw params. And that's it. And we'll return this result. Temporary, oh, right, okay. So we need to do this as a wrapped mesh. We borrow here. Then we do a let mesh equals wrapped mesh dot cast mesh. There we go. Now we're happy here. Clear screen system. We can now call here. Pass it in a reference to self.world and the context. So if I run this, it should fade away the background ever so slowly, unless of course it's happening a little bit too quickly. Nope. Okay, so I'm seeing a very okay, I'm seeing them, but I still like that clear screen may be a little bit too strong for us. I may need to make it a little bit weaker. It is kind of working. It just means that everything's a little bit muted. Just that's a little bit unfortunate. I could also apply it only every n number of frames. I mean, that would work too. What I am trying to do is apply this clear first, and then we draw the birds on top of the clear so that we still get like the full color in here. I think we're getting that. So I actually think we can maybe go a little bit faster. What are we doing for this? Let's go back to our mesh. Let's make you like a 0.1. Oh, interesting. Okay. So the tails don't last for very long now, which like that's also a very interesting and sort of like fun. They look very fuzzy now. That looks pretty cool too. Not exactly what I was going for. But it does look pretty cool. Let's make you like just a 0.01. Unintended art version 2.0. I mean, yeah. Art is simulations. Oh, wait, mouse, what are you doing to me? So a couple years ago, there was like an art exhibition, and so my wife and I went and we visited some people that were doing art, and they were like having their art for sale, and one person did computer generated art. It was sort of like this. He ran sketches. I think he was using processing or maybe something else like that. And then basically drawing very interesting patterns and then printing those out. So it was a very static art. I could see this as more of like one of those, getting like the Amazon photo container type things and have something like this. Maybe it rotates between this and several other art pieces that could be made. But yeah, it could be really cool. So now everything's gonna fade away decently quickly, but maybe not quickly enough. Also, I think we have maybe too many. Like 500 is too much for this size of world. If we drop you down to, let's see, where are you? 100. So 1/5 of the number. And I also increase this rate. So I don't want 0.1 is maybe a little bit too fast. Try 0.5. And you know what the other thing is? I want the colors to cycle faster. So I'm gonna change this back in our resource where we're changing the color speed. Color change, speed is fine. This rate, let's go back to here. And here we go. I like this a lot. Oh, now we get these beautiful trace lines and they're fading pretty quickly, but oh man, I like this a lot. Of all the ones we've seen so far, which one's your favorite? You should commit at this point. Yeah, okay. I'll commit at this point. I do like this. This is pretty good. This one's your favorite? I think I like this one the most too. I don't know if you can see, but there's like this smear in the background of like the old colors as they're just slowly fading away. And it kind of looks like the problems that the very old TVs had when trying to draw like black. They couldn't, so they have like just all the old all the colors that have been burned in are just sitting there still. This one, okay, we got multiple votes for this one. So let's go ahead and commit. Let's actually clean up the warnings. All right, so we're not using you. Background color. Okay, so we're not using a background color. I'm just gonna go ahead and comment that out because we might still do that at some point in time. Unused import white, right? We're not using you anymore. Visualize range. Oh, yes. Visualize ranging system is not being used. This is fine. I want to, for you, turn on. Allow dead code. Okay, and there we go with you. Close you all down. Okay, so in Flocking Rust, we now have basically we finished like the main part. So Boids are flocking and looking really good while doing so. Now we also have U. So in the resources, we added a U size. All right, so back to you. Here's what it's looking at. This one is still super good. I love it. All right, what's what more can we do to this? You know what? There's one last thing that I want to be able to do, which is I want to be able to resize this window. I want to be able to resize this window and have everything still work. So that way I can make it like small. I can like move it into like the half window size. I can't do that. I can only just move it around like this. Oh, that's Goose thing. So I moved it from one screen to another, which have different resolutions. That wasn't very happy when that did that. So this is going to be like the last thing before the flocking simulation is done. So the way we allow resizing to happen according to GGEZ is we're going to come to main. And in window mode, we have these dimensions, but we also have to have resizing. Move the min size. Okay, whether or not the window is resizable. So resizable is a Boolean, and okay, it's just resizable, and we pass in a Boolean. So resizable true. So if I just do that and we rerun you, now I can change the window size. Now here's a problem. Everything is screwed up when I do that. Where'd I get to the idea to do a flocking simulation? I've seen other developers do the same. Is it some public challenge or something? No, actually. So one of my friends and ex-coworkers / like Rust mentors, Tube Danny Fritz, also friend of this channel. Like he's been here a few different times. He did this flocking simulation. Now he did his in his own engine, I believe. Where he also made an ECS engine in the front end, and so he created this. And I was like, oh, I want to try creating something like that. So I did that too. He's not super active on YouTube. He used to do some streaming too, but I think he's taken a break from that for quite a while. But so yeah, I wanted to build my own version of this because I thought it looked so cool. And then I saw all the other YouTubers and streamers doing that. I'm like, oh, I really want to do that. That's just so fun looking. So that's why. Now we have this problem. I can now full screen this. That's great, but it the dimensions are a little bit screwy, and I think my box that's clearing is set to be like a smaller height. So I think as soon as this hits outside of that, it's gonna streak forever and not be removed. That being said, I'm actually, oh, the resolution is staying the same. Is the resolution staying the same but the size changing? That seems to be, I'm curious about this now. If I don't set the resolution here, if I don't set the dimensions, but resizable is true, we're gonna start off really small like this, and everything is super fine. And then I go to big. Oh, everything is still that same resolution of like not small. Yeah, it's scaling, but I don't know what like the decision for scaling is. Like this is really low resolution. What is the default? 800 by 600. Ugh. 800 by 600. So if I do 1920 by 1080, okay, but that's a problem. If I then change, yeah, I need to handle the resize myself. How do I want to do that? So if we start off with this, like we're starting with 1920 by 1080. So this is 1920 by, oh wait, no it's not, I lied. This is 1920 by 1080. This also happens to be what I'm streaming out at, so it's perfect. Now if I want to resize this and I take this down a little bit, then I need to catch that this window screen size, like that this has changed now. And then I need to reset the size of the window, and I need to recreate the I don't know, the box that removes things. Is there an event? It's like, I wonder, is there more in here? Okay, there's mouse button down event. I don't care about that. Up event, motion event, wheel event, key event, key up event, text input, focus and quit. Okay, resize event. Here we go. Okay, so we have a context. We have I assuming this is the new width and the new height. So when this happens, I have immutable access to self. We can now set the drawable size, I think. But there's a way to do this. I can do graphics. Drawable size is a getter, right? This is a getter. Set drawable size. Sets the window size resolution to a specific width and height. So if we do this, context, you become context here. Then we have the width and height that are passed in here. Do we also have to set it into window mode too? Like the window? I feel like if I do that, this can't return a result, which kind of sucks. So I have to unwrap you. if I just do that, what happens? I think like the meshes might need to be created. Oh, it doesn't stop. Wow, okay. That's not good. Quit. Okay, it did not like that at all. That was not a very happy thing. Okay, so I think I also have to send the window mode. So let's do that beforehand. So we're gonna do is it of context or let's see, window. There's this entire window mode. Window mode. There's no set. Can I do off of context? What you call not good, I call possible cause of an epileptic attack. I do not disagree with you. Okay, so we have to set drawable size. There's one more thing that needs to be done here. Set the window size resolution to the specified width and height. Okay, so we're doing let window mode equals context, window mode, off window mode. Okay, so there's doing window mode dot width equals height, window mode dot height equals height, set mode, context, window mode. Okay, so that's what this is doing. This is fine. I mean, I think that it's fine. I could also just go straight in and set this myself. Okay, what happens if I just try to do like one go full screen? Nope. Nope, nope, nope. Okay, so I didn't try to change it again. It just didn't like that at all. What's going on with that? Let's say in draw, we don't do any of these. I just have the present. Yeah, okay, so you're unhappy. We may have to look into how to properly do that in the documentation. I'm thinking like I remember doing this a long time ago, but it was in a previous version of GGEZ. They may have changed how it's supposed to be done. So we're gonna have to look into that a little bit. This is not happy. So that's not supposed to be what this is not the way to do it, essentially. But this is still really cool. So it is 8:30. It does mean I have to head on out and do, you know, the rest of my day. I think that if I set the resizability, I will call this project done at that point in time. So I'm gonna go ahead and make sure I push up all these changes onto GitHub. Let's see. I think that's gonna be it. We've only got like one little section left of this to do, and it's gonna be super exciting to call this done. After we're done with that, I think just a little bit of cleanup with the ECS library and maybe setting up some GitHub actions and publishing it to the store. And then it'll be ready for the next project or whatever that is. So anyways, thank you everybody for stopping by and doing this.